Our mountains are special. Born from global forces and always being worn down. It takes millions of years and the energy of a planet. We're spending some time in this wonderful place to show how our Earth is making mountains. The world can be split into roughly 7 continents: Asia, Africa, North America, South America, Antarctica, Europe, and Australia. Sometimes Europe and Asia are considered one landmass, and we call that Eurasia. Our story in the Alps begins as the African continent moves towards the European continent around 65 million years ago in the Alpine orogeny. When 2 continents collide, they can push some of the land upward to make mountain ranges. The Alps themselves cover 8 countries: Italy, Germany, Austria, Slovenia, Switzerland, Liechtenstein, Monaco, and France. They stretch across 1,200 kilometers of Europe and create a geographical boundary within the world's second smallest continent. When they were created, they'd have been the size of the Himalaya, but over time, chemical and physical processes have worn them down to the height they are today, Mont Blanc being the tallest among the Alps at 4,809 meters. Our journey starts at Chamonix, in France, as our team get their stuff together and head up to the Glacier de Tours to take refuge in the Albert Premier hut.
So we're just heading up to this little glacier up here, which isn't as little as you might see from here. That's very far away. But once we get up there, we're going to catch Kilcart at the top, and then we get a short walk up to the Albert Premier hut. We're staying there for the night in the hopes that there's some stuff in good condition tomorrow for us to get out on the routes.
Cable cars make it really easy to get around in the Alps, but sometimes you just have to hike. Carrying all our filming equipment and the safety gear we need, we head high, past the snout of the glacier, and see signs of it beginning to retreat into the mountains almost straight away.
Nice thing about mountain huts is dehydrated food. I reckon they eat better on the space station actually than over here. You can order dinner inside, but that's not for us.
To be safe in the mountains, you've got to go out when it's cold. Unfortunately, that means very early in the morning. So after heading out for some last minute snaps, we head inside and get to bed.
So it's 3:25 AM. We've just woken up for an Alpine start. So a luxury breakfast of cereal and dried milk and a bowl of coffee. We're off to climb the Petit Fourche and the Tête Blanche. We're up there quite early. The conditions are still good, nice and cold. And then back down in the valley by lunchtime.
Safety is key in the mountains. To find out how they're changing, we need to be in them, walk on them, see them firsthand. But the mountains are full of danger, and we need to be ready. The scale of the mountains is hard to comprehend. They're so big, you almost feel lost in them. It's a very humbling experience. The Tour Glacier is massive. Interestingly, all glaciers move. They pull down the mountain under their own weight. The Tour Glacier moves at a rate of 240 meters every year. That's 50 centimeters every single day. At its longest point, it's 5.3 kilometers long and has an area of 8 kilometers squared. The glacier is surrounded by 3 impressive mountains: the Aiguille de Tours, Aiguille de Chardonnay, and the Grand Fourche, where our team have just summited in very windy conditions.
7:45, and we set off this morning 3.25 hours ago, so it's taken us 3 hours 45 minutes to get to the Petit Fourche via the Tête Blanche, which is just over the horizon there. And it was a little bit sketchy coming up one of the patches because it's so warm. The snow isn't really in great condition.
The day continued to heat up, and you don't want to be out in the ice on a hot day. Ice starts to break off, rocks start to fall down the hill, so we made our way back into the valley and down to Chamonix to meet up with the rest of the team. We needed to find out when the weather was going to change so we could head back to the mountains safely.
So obviously a great way of knowing what the weather's going to be up to is listening to local weather forecasts. But if you want to do it yourself and you want a bit more detail, it's looking at these things, these surface pressure charts or synoptic charts. And these basically tell us what the weather's going to be doing over the next few days, which is great for expeditions. It's great if we're going to be out in the mountains. And there's lots of different things to note on here. There's blue, red and pink lines. There's these lines that go all the way around. There's big black lines as well. And all of them mean different things. So this is 1 o'clock last night from our expedition, and we knew that there was going to be some bad weather coming in. We saw that last night. We actually had an attempt on one of the mountains lined up, but we couldn't do it because we knew there was going to be a storm. And these different fronts, they're called weather fronts. We've got a blue one, which is a cold front, red one, which is a warm front, and then this one is an occluded front, and they're all a little bit different. But basically, when a cold front moves this way, you can tell by the triangles which way it's moving. In front of it, there's going to be a bit of bad weather. So we knew that this area we were in, France at the moment, there was going to be that storm. So we chose not to go out onto the mountain. And we saw that as it moved across and into, well, today, and then later on, that's going to create a bit of a nicer weather because that's moved on, it's moved out the way, and you get these nice separated areas which are called isobars. And normally, when these isobars are far apart, these lines that all match up, it means that there's not a lot of wind, and then when they're close together, somewhere like up here, it means that there's a lot of wind. So you can tell lots of different things from these charts. I know that moving on into our expedition, into Thursday afternoon and then Thursday night, there's going to be high pressure over us, which normally you get high pressures and low pressures. Low pressures generally mean bad weather, high pressures generally mean good weather. And as we move across the week, then we can see what's going to happen on our expedition and plan a few days in advance. Always good to know when you're at home, but even more important when you're out in the mountains like we are. You can see up there at the moment in the mountains, it's actually quite cloudy, but that's not the worst problem. We're actually in the middle of a heat wave at the moment, so the snow, especially when you're up high, is getting hot, and you don't want hot snow, you want cold snow and you want it to be nice and stable. So especially on expeditions, it's quite important to actually forecast the weather, know what the weather's going to be like a few days in advance.
With stable conditions on the way, we wanted to get back into the mountains to find out what processes are currently forming them and shaping them. If the mountains were once 3,000 meters higher than they are today, what's wearing them down?
Today an early start for the anti-air team. We come up on the first train from Montenvers up to the Mer de Glace, this glacier. It's a perfect example of a dry glacier, and it's always been affected by things like climate change and the changing seasons and everything. So we're going to head down the ladders and onto the glacier and spend the day down there.
The Mer de Glace literally means sea of ice in French. It's 7.5 kilometers long and 200 meters deep. But if you take into account all the tributary glaciers that feed into it, it's one of the longest and largest glaciers in France. It starts way up here in the mountains and used to travel all the way down to the valley floor. The team are close to where the end of the glacier is now, getting ready to head onto the glacier itself.
The way down onto these glaciers, you have to go down a series of quite steep ladders. So, lucky enough, we're all confident enough to go down there. But yeah, they are quite steep, to be fair. So there we are. Not a steep ladder, some bits quite technical, but you know, it makes it so accessible that lots of people come down. And you've got to wonder, you know, what's that doing to this glacier? It's going to have some kind of impact. Might not necessarily have a big impact, but every little thing that we do as humans will have an impact on the landscape.
I'm not sure how something that isn't living can look unhealthy, but the Mer de Glace looks like it's ill. It's a lot smaller than it used to be, with lots of rocks scattering the surface.
We've headed up quite far from where we came down the ladders actually. You can kind of see the station in the background up there. We're heading north of this glacier now. And it's starting to get a little bit slippery, and when you're on location like this, you kind of always need to be aware of where you're stepping, what you're doing. So crampons on, helmets on. Keep looking ready. And happy as well. Yeah. As always. So we're going to head up to one of the rivers just to see how it's doing, how much flow there is coming down. It's really warm today actually. We're in a bit of a heat wave, so it is going to be flowing quite fast. There's a lot of water going down it, so we should always be careful. So right now we're on one of the most important glaciers in the French Alps in Europe. It's called the Mer de Glace. And it's a beautiful glacier that is absolutely huge. And it runs right from up there in the mountains, comes all the way down through here, down to the valley. It's around 7 kilometers long. In places it's 200 meters deep, and it's always changing. But it's nothing like it actually used to be. You can see all around evidence of where the glacier used to spread. From right up there, you can see the scar lines on the mountain, and it carved this whole valley out. So this particular glacier is a dry one, and what that means is that there isn't a subglacial river that runs down in between the bedrock and the glacier itself, lubricating the bottom of it. So it's still quite active though. It moves at around 1 inch an hour up here on the Mer de Glace. So we're actually moving downhill right now. But this whole system, you can see meltwater running around on it anyway, and it doesn't necessarily go down to the bottom of the glacier. But what it's doing is carving out new lines through it and heads down into it, and will create subsurface lakes and channels that move through it. So it's always changing. And through the winters and the summers, the different seasons, you get accumulation in the winter where more snow kind of heads down and will build up on it, and all that snow then will melt through the summer, and you get the meltwater heading out. And through the channels, through these systems, what will happen is you'll have the channels moving down the rivers and down in the crevasses, and then they'll come out of the glacial snout, which is the end of the glacier, which is much more down towards Chamonix Valley. But as we said, this is a very active glacier that's very, very big. And the reason it's moving downhill is because it kind of gets pulled downhill by its own weight.
What makes glaciers special is their ability to flow. They move down the hill like very slow ice rivers, and all glaciers do this, no matter if they're the size of football fields or cover huge areas like this one. The way they change the mountain though is by plucking out rocks along the way. They can scrape and scour the mountain to carve huge valleys. Over time, when they melt, they leave those valleys in the mountain for us to adventure in, with only indirect evidence the glaciers were even there at all.
So as it gets pulled downhill, you start to get crevasses forming, cracks in the glacier, and that's where this meltwater that runs across the top starts to dive down underneath and carve new channels, new landscapes within the glacier itself. And if those channels don't find an out somewhere, then they start to build up. And that's where we start to get these glacial lakes forming within the glacier itself. And they can build up and build up and build up. And then after a while, if they get too big, then the front of it can burst and all that meltwater runs out and into the valley. And that's exactly what happened around 100 years ago, where one of those dams burst and it all went down into Chamonix Valley and run right down the valley and caused a lot of fatalities. So the study of this water, like the crevasse we're in right now, and I can tell you for a fact that, well, I can't see the bottom of this crevasse. The study of this meltwater that runs through here is called glacial hydrology. And it's something that scientists are working on quite closely at the moment because, like we say, all this has implications. If this meltwater runs right down to the bottom of the glacier, it has an implication for how that glacier moves and how it acts. So it's all important data to collect.
Okay, go. And we're down safely. It's a little bit loud down here with the volume of water going past. It's pretty cool. So on top of the glacier, we've actually seen a lot of this milky kind of ice. And it's not milky in that colour, not this kind of white colour, because you've actually got something else in the ice. It's not as though somehow there's another material in there. What's actually going on is that the ice is a different shape, it's a different structure. And so it's formed from snow, and you end up with little tiny crystals that are bouncing off loads and loads of light. And so that makes it look very white, like how a white t-shirt reflects lots of light.
The colour of a glacier actually impacts how long it lasts. A glacier with white ice on the surface can actually repel a lot of the sunlight that hits it. We call it a high albedo. That means the glacier doesn't really melt much, but when the glacier starts to accumulate rocks and sediment on the surface, they can absorb a lot of the light, making the surface of the glacier heat up. That means along with higher average temperatures, we see a shrinking of glaciers around the planet, and a lot more mountains have no glaciers at all.
Ice is a really interesting material. It has an orderly lattice structure, like a crystal. It's brittle so it can break when under stress, like if you drop an ice cube. But it can also flow like a river, a huge ice river or a glacier. A glacier moves via three main mechanisms: creep, slip, and sediment deformation. Creep is when the internal lattice of the ice moves, so the water molecules creep over each other to move the structure. Slip is when the glacier flows on meltwater underneath it. And sediment deformation is when the sandy glacial bed changes and moves. So all of these things cause the glacier to flow down the valley.
We've come a bit lower down on the glacier now, and we're in one of the meltwater streams that's coming out of the glacier. We're using the same meter again. I'm going to dip it in, just hold it there for a little while. It's quite ferocious water, so we don't want to lose the probe. So interesting, that's coming through as quite more acidic actually. We've got about 5.5 there. So that might be where it's going over the rocks, and we've had a lot more of the moraine entering into the water. And it's just picking up the different chemicals that are in the rocks, and that's making it a bit more acidic. So that's quite an interesting one. It's quite turbid here, so there's a lot of movement in the water. So we might expect to see a little reading on the dissolved soliton. So we'll just test that out as well. So actually, yeah, we have a very low reading, but a reading nonetheless. So just maybe a little bit of those rocks getting into the water, mixed in with maybe some of the other stuff that's been on the glacier, maybe some organic matter from further up and from the sides of the glacier, just giving us a little reading there. So very interesting, and we'll test that further downstream and as we get into Chamonix and see how it changes as we get down the glacier.
As we wrap up our expedition, we know a lot more about this area than we did before, and that's what science does. Over millions of years, the Alps have grown, and processes like these are wearing them back down. It's just how it works, and all part of how the Earth goes about making mountains.
Go! You know what that means, guys? That is a wrap! Hey! Experts Alpine, done and tested. I want it in.
Oh, come in! Yeah.